and an iteration schedule so that I'm either A, delivering software, or B, having these checkpoints where the user is going to come in and see where we're at. It's making sure that we have sign-offs. So at the requirements phase, requirements should not be passed into, here's something we can actively code against, until the quality team has reviewed the requirement and signed off on it. Signed off that this is a testable requirement, that the non-functional as well as the functional requirements have been captured. You want to look for things being contract-oriented, because contract-oriented definitions set themselves up for testing. In particular, they then lead into the practice of test-driven development and utilizing unit tests to define the code before you've actually implemented the code. In the development process, so the use of unit testing and test-driven development, utilizing build management, so I have a common process every single day. And when I look at that common process, so like I said, we see in best practice organizations that all code goes through some form of peer review. This means that you can do this either online, you can do this person to person. There are going to be times where there is, as you move in towards closing in on shipping code, that there may be a peer review that happens at a formal, higher level sense with a triage board meeting every day to say whether a set of changes can actually be checked in, because now the code is stable. People shouldn't be changing anything. So if I want anything to happen, someone's got to approve that. But at the informal sense, on a daily mode, you need to be able to have developers sit down. You want to have more senior developers working with more junior developers to, one, teach them and train them, two, to talk through what did I do and why did I make the decisions I made. There have been a number of studies that have been done that show that just using informal peer review practices will remove a tremendous number of defects from your code. And one of the things that's interesting is that knowing that my code will be peer reviewed actually drives developers to write better code in the first place. Another piece that goes along with that is the use of static analysis tools. So we've seen a growth in the market around tools to help me do static analysis. And a lot of the driver has been based on security and the fact that we now recognize that there is more of a requirement for our systems to be secure. But static analysis has lived for many years, and it's had kind of mixed results in its success, often because static analysis tools throw out many false positives. In addition, they are going to throw out often lots of warnings that I may or may not really care about. So these tools need to improve so that we see less in the false positives and to give us the flexibility to really determine what I care about or not. By utilizing static analysis together with peer analysis gives me a great comb to shake the code out, to comb through and find those needles that I can't find in the haystack, hard to find bugs that I can't find any other way, and something that should happen every day before code gets checked in. Once I've passed through those and I can check code in, so it's passed its unit test, it's been reviewed, it's been source scanned, and there aren't any errors or any warnings that we're concerned with, now I can check into the build, and I want to automatically build. I want to run tests to verify that I have a good build, and then hopefully kick off some automated testing along with the next day's worth of manual testing. So you see this flow that should occur every day, and something that should occur with a lot of emphasis, not only at the tester level, but at the developer level. So to summarize all that together, there are these changes in the market that we're starting to push out web services that we are going to, under contract, under an SLA, have business partners utilize. If we're going to start to have better interactions with our end users, if we're going to be responsive to the business and provide this flexibility, all of the, on one hand, the market hears all of this message around flexibility and reliability, and at the same time, we're going to be global class, enterprise class, global class being 24/7, able to work multi-region across varying rule sets, varying language sets. If I'm going to do that, I really need to up-level my game. Agile is a good way for an organization to be more responsive, but it can also be a way to help drive quality. To drive this quality, that I have a mentality around driving out defects and building something that's stable, building something that I understand the dependencies, that's documented, so that, and something that I can change, retest, and know the effects that I'm going to have on all of the other applications that may be utilizing that service. So you need to have quality throughout the development lifecycle, right from the requirements on through what we deliver. You need to make sure that you are consistent with a daily repeatable process that all of the participants follow. The more repeatable you can make your day, the more productive you will be, and it'll just become something that's natural to us, which helps in and of itself drive defects down. And then utilizing static analysis as part of that daily process, as part of this moving into an agile world, gives us a number of automated benefits back. That second set of eyes to understand what's going on and find those kind of errors that are really hard to flesh out. It gives us the ability to drive and ensure that our code is meeting standards. It gives us the ability to find where should I focus additional testing efforts by looking at the metrics in the code. Where is the code the most complex? I need to make sure that my testing organization is spending the most time on automation around those pieces. Where is it highly coupled? Where is it? So finding these various metrics will hone us in to help us know what should I automate, what should I test first, where are the places of highest risk in this code. So I think if you can pull those types of things together and you can pick up on the many tools that are out that are growing and helping us with automating these processes, you'll find that your organization is much more successful and can make this transition both into Agile as well as making a transition from being a testing-oriented culture to a quality-oriented culture. So with that, I will turn it back over to Ben to talk a little bit about how Coverity plays into that market.
Sorry for the delay, everyone. But thank you so much, Tom, for that piece of information on the Agile development process. Very comprehensive. And now I want to talk about the static analysis side of things. And going back to the poll results, I noticed a lot of you either didn't track as a metric the number of defects that you detected before QA, or there were still plenty of bugs to be found before you ship your product into QA. So we're going to talk about a technology now, static analysis, that allows you to find more of these bugs on the developer desktop. Before I launch into that, I do want to pop open another poll. The next poll question for you is, what is your familiarity with static analysis? So go ahead and click that, and I'll get started on my slides. So Coverity has been around for the last 5 years, and in that time we've accumulated 350 customers worldwide, large software development organizations who are developing very complex software. Some of them are Agile, some of them are traditional development environments, and we're able to provide value to them by finding these defects early in their software development process. And in fact, we ourselves are also a proponent of the Agile development process. We use Scrum here at Coverity.